This is the screencast for section 6.1, example 4. We're going to use the fundamental theorem this time to solve the initial value problem. So we're going to find the solution to the differential equation f prime of x equals e to the negative x squared, for which f of 7 equals 3. So that gives me my point to help me solve for my c value. Alright, so dy dx equals e to the negative x squared. So I'm going to multiply both sides by dx to get the differential dy. And I'm going to integrate both sides, but I don't know the integral of e to the negative x squared. So this is where the fundamental theorem kind of comes into play. We can come up with an expression for the integral from a constant to the variable x of e to the negative t squared dt plus c. So now this setup represents an antiderivative that I don't know, but it still represents y. Not the derivative anymore, but the antiderivative. Alright, so now the question is, what should that lower bound be? What should that constant be? So if you remember from chapter 5, we're going to pick that lower bound to be our x value to make things a little bit convenient. So I'm going to pick 7 for a, and now I can plug in 7 for x and 3 for y, which will help me solve for c. Because if 7 is my upper bound, now the antiderivative from 7 to 7 is 0, so 3 equals 0 plus c, and I get that c equals 3. So now y equals the antiderivative from 7 to x that I don't know of e to the negative t squared dt, and then plus 3, and then of course by the fundamental theorem, the derivative of y, so f prime, would be e to the negative x squared. And then the plus 3 would be a 0, because the derivative of 3 is 0. The now try problem number 21 says solve the initial value problem using the fundamental theorem. Your answer will contain a definite integral, so they kind of gave you a hint that your answer is going to look similar to example 4 here. So first, I get the differential dy, and now I integrate both sides, but of course I don't know the antiderivative of sine of x squared, so I need to use the fundamental theorem and make that the antiderivative from the x value 1, and I chose that because of the initial value that I was given, to x of sine of t squared dt plus c. Then I plug in my point that I was given. X is 1, y is 5. Now the antiderivative from 1 to 1 is 0, and c simply equals 5. So my final answer is y equals the antiderivative from 1 to x of sine of t squared dt plus 5. Because then, by the fundamental theorem, the derivative of y, so dy dx, would be sine of x squared, and then plus 5 would be a 0.